This is problem number 6 on exam 3, the rework. So the part A of question number 6 is asking what the current is at point B. So I'm going to first draw in what current 1 is going to take the path. It's going to come up here, come up here. So everything in blue is going to be current 1. And due to the junction rule, the currents at each one of these points is all going to be the same. Since we were already given that the current at point D is 1 amp, we automatically know that the current at point B is also going to be 1 amp. So I'll just label that down here. The current 1 equals 1 amp, and current at point B equals 1 amp. So now moving on, at part B asks about what the current is at point E. So point E is going to be a different current that's going to come across here, 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 and here. So this is going to be current 2. And current 2, we're going to use loop law, the loop law. So we're going to start with 0 volts, so 0 volts. And we're going to subtract the 4 ohms from the resistor times current 2. And this is equal to, since we're coming up to the negative terminal of the battery, it's going to be negative 12 volts. Now we solve this out, and the current at point E is going to be 3 amps. So now we can move on to part C, where we're looking at the electric the potentials at the different points. So first off, we're just going to label these potentials. So since this is ground, this is going to be 0 volts. And so right off the bat, anything connected on this line is going to be on 0 volts. But the only thing here is going to be A. So at point A, the voltage is going to be 0 volts. So I'll just write that down here. Now moving on, so we have point D. Now point D is right off the 12 volt battery. There's nothing stopping any current, so it's just going to be equal to positive 12 volts because it's coming off the positive end of the battery to the ground. So that's VD. Just put in these other labels here. So VD is going to be positive 12 volts. Now moving on to point E. So point E is going to be, to find point E, you're going to have to do the equation of V equals IR, V equals I2R. So V equals 3 times the resistor 4 ohms. So the voltage at this point is going to be 12 volts. So this is going to be equal to 12 volts. And it's actually going to be negative 12 volts because it's on the negative side of the battery going to the 0 ground. So at point E, it's going to be negative 12 volts. Moving on to point C and B. So we are again going to do the same equation we did before, except this time using the new current and new resistor. So current 1 times the resistor, V equals 1 amp times 6. So V is equal to 6 volts. Now this is also going to be negative since it's on the negative side of the battery. So it's going to be negative 6 volts. And now going across here, we do the exact same thing for point B, and you're going to get the exact same answer. So at these 2 points, the voltage is both negative 6 volts. And so it makes sense because along the lines, these are all running in parallel with each other. So each one of these lines should all add up to 12 volts, and they do, because we have 12 volts here, 6 and 6, it's another 12 volts, and then across here we have 12 volts on the bottom.